Okay. Good afternoon, everyone. I'm Mukund Bhagwat from Aurubis, expert in energy and climate. So what we are saying here is Germany's largest industrial heat project in a city, Hamburg, which has already declared that they want to decrease their CO2 footprint with respect to 1990 by more than 80%. And this is one of the way they are able to achieve it, namely using excess heat from a very large integrated copper producer, which is only 5 kilometers away from the center of the town, but still it is very much active, very environmentally controlled, and at the same time producing excess heat, which is now being used for a new district, namely Haven City East neighborhood number 1, if you see on the top. That is where already the discussion started for using the heat and providing it about 5 years ago. From 2014 onwards. The project itself was designed, engineered around the same time as we started with developing the H-DisNet technology. Of course, this particular project, which is being shown here on the picture, is using very high temperature heat, so 90 degrees and higher to go in, and what is coming back is 60 degrees. But at the same time, we are aware that after, let's say, the whole high temperature heat is utilized, we still have more than 10 to 15% of all our energy input as low temperature heat. And at this moment, there was no technology available to provide the heat economically and with time shifting, that we are able to give it at the time when people need it. And that's why we started with working with H-DisNet project. So what is behind it? The project scope and complexity are unique and show the potential for the heat change. Essentially, it's a large project. At this moment, we are discussing 3.7 kilometer pipeline using high temperature heat. But essentially, we want to later on go for even higher one. Right now, it is about 8,000 households which are provided with clean heat. I will explain later on why it is clean. And later on, when the project is developed completely, we can even serve 25,000 households. What we are trying to do is, because the heat generated is by burning sulfur as a part of copper production process, there is no carbon dioxide coming out, and essentially we are saving for 10,000 cars equivalent for a year. And when we are able to extend this heat completely, then we can save even 140,000 tons of CO2 for Hamburg city, if Hamburg city will use it. In addition, within Aurubis, we have been able to save a lot of water, 12 million cubic meter of cooling of Elbe water per year, because if we do not provide this heat to district heating, we have to cool it before we can transfer it to Elbe in order not to harm the fish from Elbe River. So how does it work? Essentially, on the top, you can see the furnace on the left is burning copper ore containing sulfur. Sulfur goes to sulfur dioxide. Sulfur dioxide becomes H2SO4, sulfuric acid, which is used for many chemical things. And that has been captured by extra investment and provided to district heating by a pipeline for which Enercity is the utilizer of this heat in order to provide it to others. This has been already recognized by several awards within Germany, and essentially the head of section, Mr. Thomas Herden, Federal Minister of Energy and Economy, said the external use of industrial heat makes a significant contribution to the city of Hamburg's climate protection goal. And with the help of industrial heat, the emission level in Haven City East falls below the demanding emission threshold for the new development area. What is important is this heat is being developed at high temperature, but with H-DisNet, we have ambition to also use the low temperature heat, and there is a lot of it available. Thank you.
Okay, thank you, Mukund, for that insight and what happening is in Hamburg and what is the potential of first high temperature and then second low temperature heat. The next presentation is from Markus Thürenbeck, who's unfortunately not available because he needs to go to a business trip. He's on a business trip at the moment, not able to connect, but he sent me his notes and I will give that presentation. So Markus Thürenbeck is from Thermoflex, and Thermoflex is producing material for district networks, but also for building technology in buildings, heat distribution technology in buildings. The perspective, oh, I lost the presentation for some reason. One moment, please. Okay. It's again here. Okay, so their perspective is first on producing technology for the district networks and implementing planning such networks. So they know that quite well. They're also doing water distribution, and that links a bit to the thermochemical technology because no insulation is required for water distribution, also for thermochemical fluids. It's not necessary to insulate the pipes. They have a broad perspective on what is happening at the moment in district heating networks. So there are 4 generations now. District heating started with steam in the 80s, 1930. Then it started with the second generation, which used pressurized hot water above 100 degrees centigrade. Now we have the 3rd generation being implemented or is currently the state of the art. So we have pressurized water below 100 degrees centigrade and including a lot of sources in that technology. And what is expected as a 4th generation is the intelligent integration of further networks, reduction of temperatures, integration with other systems, with heat pumps mainly, and making such networks kind of more smart. That's a development that is currently much ongoing in the Scandinavian countries and also in Netherlands and so on. So that is a current situation. I asked him to tell what he expects will happen in future. That's next slide. So they are involved in projects that are doing even lower temperatures, going below 40 or 30 degrees centigrade. That's what they see as 5th generation, using geothermal sources or waste heat. So that's their interest. But that requires underfloor heating of 30 degrees in buildings, which we heard already for other systems, or the use of heat pumps to get hot water in the buildings. So even further are going projects with so-called neutral temperature levels. So that means we have really temperature levels of 15 to 20 degrees from geothermal temperature or even lower. And then it's really heat pump solutions and local storage that enable us to have the temperature levels that we want to have for buildings. Question is how the thermochemical technology links in there and what is the perspective in that context. So what is interesting for the district heating is first the benefits of no thermal losses during transport, which means we have no thermal insulation that is required. We have a cheaper network, and we have material lean components in the network, which makes things much simpler. Then we have the possibility of storage, which means that not only transport is, of course, free of losses, but also storage. And we can have a much simpler network management if we have the opportunity of storage. And then we have the add-on of humidity control, so they can offer further services in the network. It's first humidity control you can offer, and second, of course, cooling is also a thing that can happen at the same time with heating with thermochemical technology. We have also barriers that we have to take into account if we think of bringing the technology to the market in that context. First, we have corrosion with the thermochemical fluid, and we have worked a lot of about corrosion in collaboration with Thermoflex. We checked components, first pipes. They produce plastic pipes, so that problem is solved. Then pumps, of course, and these things. But we discovered that there are solutions for all of these aspects, and it's possible to transport a corrosive fluid in a pipe network. Then next barrier is the exchange of the technology that is required. So it's really a new technology for the network and for demand and supply side. So that requires exchanging things, and that has to be taken into account. And a third barrier from Thermoflex perspective is the technology readiness level, which is at the moment at about 4 to 6. That's what we are developing. And there are some steps to go in pilot projects or whatever to implement the technology at the market. Yeah, that is the perspective of Thermoflex. I hope I presented correctly. And we have one short last presentation here in that block from Accelopment about the stakeholder perspectives and especially addressing various benefits, potentials, and possibilities. Damien, are you ready to present?
Okay, can you hear me?
Yeah, I can hear.
Okay, perfect.
Yeah.
My name is Damian Berli. Me and my partners at Accelopment support the H-DisNet project with regard to exploitation since 2018. And Marco, could you please go one slide ahead? In the next step, I will introduce the perspective of stakeholders quickly. What you see on the slide is the result of a stakeholder mapping, which was conducted by the consortium as part of the exploitation activities. Key stakeholders were divided into 3 main groups. The first group was characterized as energy supply. Key stakeholders here are especially manufacturers providing waste heat, as well as intermediates such as district heating operators. The second group was characterized as energy demand. It consists of various stakeholders such as private and public buildings, larger communities such as cities, as well as industrial sites. The third group finally was characterized as various supporting areas, ranging from policy to economic and technological aspects. In order to complement the already existing knowledge in the consortium, we conducted several interviews in the course of the summer, focusing especially on supply and demand side perspectives. The main objective was the identification of challenges and opportunities related to the exploitation of 2 of the project's most important or most promising applications, industrial drying and humidity control in buildings. These applications were selected due to their positive financial and also ecological prospects. More specifically, the H-DisNet technology has the potential to reduce fuel consumption for drying by 85%. In addition, it could serve as an affordable, energy-efficient solution for humidity control in buildings. The results, could you please go one slide ahead? The results of the interviews are depicted here on the slide. Basically, most of the participants were interested in the potential of the technology. With regard to the specific stakeholder groups, we found varying interests or varying highlights. Participants and experts in the field of district heating argued that the sector was quite traditional and thus slow in adapting to new technologies. To progress in this area, they recommended the targeting of small-scale networks, since these would involve lower risk and also a lower investment. The second group of industrial stakeholders, on the other hand, were especially interested in the possible use of low-temperature waste heat. However, they characterized the current technology readiness level as a key barrier for market exploitation. So consequently, they recommended to conduct further pilot projects in order to generate additional data on the technology. Participants from the building sector finally highlighted the increasing demand for energy efficient humidity control in private as well as public buildings. It was recommended to focus on niche markets, for example, such as clean rooms. In a second step, it would also be imaginable to have a small affordable solution for the mass market, which had to be developed. They further highlighted that such a development should also be aligned with manufacturers of ventilation systems and heat pumps. So in conclusion, the perspective of stakeholders regarding the potential of the technology is mostly positive. However, as one of the typical drawbacks, especially the technology readiness is a key barrier to the market, which the consortium is trying to address by the introduction of pilot projects. That's it from my side.
Okay, thank you, Damian, for that overview of the stakeholder analysis within the project. That is one perspective of stakeholders. The stakeholders have responded to our survey. I would like to. I mean, you have seen the technology today. You've seen modeling simulation, the application in the demonstrators, and in the case studies. And we are currently looking how we can implement the technology in future. And we would like to get your comments to that. If you how we think that could be approached, where you see the potential, maybe adding more perspectives to the stakeholders that we have seen at the moment. So please give us your feedback. Are there any comments for the future of the technology, where it could go, what is the right direction to develop that, or any ideas, any opportunities you see?
I have one question actually regarding the heat recovery that Aurubis has done in Hafen City.
Yes, please go ahead.
I wanted to ask you at which stage of the copper production process you have implemented the heat recovery thanks to the thermochemical technology.
Yes, thank you for the question. Can you hear me?
Yeah, I can hear you perfectly. Thank you.
Okay, so thank you for the question. As I explained, at this moment, the heat recovery is at high temperature. In the first place, we recovered the heat at maybe even 400 degrees, 200 degrees, convert it to electricity. Then whatever is remaining, we are, let's say, managing it at 90 degrees and providing it to the district heating network, and it is coming back at 60 degrees centigrade, which we are again heating using the excess heat which is available at higher temperature. But in all that process, we have a lot of exhaust heat going out from furnaces, etc. And it is that heat in the building, which is also about another 10%. So to give you an idea, we have something like 1 terawatt hour of electricity and 1.5 terawatt hours of gas-based energy input. In addition to that, we have this chemical heat coming from sulfur, burning of sulfur. So there is a lot of heat available. In fact, all the internal needs are fulfilled. That's why we are supplying it to district heating, but we still have a lot of heat available. So if we can have this technology perfected on a industrial scale from this hybrid network, thermochemical network, then we can supply even the larger region using this excess heat. I don't know if it answers your question.
Yeah. That was clear.
Okay, thank you. Just to continue, there is, according to a European study, there is a potential for excess heat at low temperature, which can cover almost all of the air heating need of the buildings. Let's say 10 years from now, provided the buildings are insulated, etc., so that there is no further loss of heat due to the building stock. But as mentioned earlier by partners, when the buildings are already, let's say, energy efficient, then low temperature heat makes it even more efficient by not losing any energy during the heat transfer, because it's a chemical energy and it is not, it does not require any insulation.
Yeah.
Yeah, it was one, maybe to add to that, it was one conclusion from the Hasselt case study that we saw for local solutions that you can connect with a thermal district network, as it is done here in Hamburg. That is the most efficient solution. But if it comes to longer transport, maybe to the outskirts of the city or to low demand areas, then it makes sense also to include the thermochemical technology with its potentials.
I think it's important to see, you can see a lot of water going there. So normally we can load our inland barges with thermochemical solution and transport it to 50 kilometers and then take that heat, the chemical heat, for, as mentioned by Philip, for other less dense area which are still connected with the inland waterways.
Yeah, that's interesting from the perspective of a district heating operator, I guess, and this should be something that I hope it will be further developed within the project or future projects related to thermochemical technology.
Oh, that is very good feedback. Thank you.
Another point is the possibility to store this thermochemical liquid also for a long time without losses. I mean, in comparison with hot water, so we need once less volume because the energy density is higher, and we don't need to isolate, so we don't have to take account on losses.
Okay, thank you.
Welcome. Further questions or comments or whatever?
I think, Philip, if I may, Mukund here, it will be interesting if anybody is interested to form a new consortium for the further stage of this project. Please inform your interest to Philip so that we can take it further.
Yeah, definitely welcome. Yeah. If there are any ideas of developing, applying that, I mean, we are looking for pilots, we call it, so that we bring that from the demonstrator level to the real environment applications and develop the technology in these environments in the end to the market readiness.
The reason why we are saying it is I follow quite well the regulatory discussion in Brussels. And right now, this European Green Deal, which is coming up, is requesting very high decarbonization in all the member states. And there will be a review of all these national energy climate plans, particularly for heating and cooling, once they have submitted their proposals. And this is the technology which will be ready, we think, in 5 to 10 years from now, but which will give solution at the right time when those member states who are lacking today in energy efficient housing, we will be ready to help them further to decrease it to zero.
Yeah. And from the perspective of the technology itself, all the applications that involve humidity control, drying, and all these kind of controlling humidity in air, that is interesting because the technology provides that that service automatically. And these services are usually developed in competing technology. They are developed with high energy effort or with other problems of hygienic problems and these things in buildings. So that's quite interesting to develop further implementation projects on that basis.
Just one question.
Yeah, please.
When do I don't know what is the timeline now of the project, when it's going to end, H-DisNet, and if you are planning already a new proposal for next years, or what is the timeline that you have in mind now, and also for the
yep.
next step?
H-DisNet is ending in December, end of December this
Okay.
year. And there are several small proposals under development, but we are also interested in larger collaborative projects again at EU level. So that is, we are looking for opportunities at the moment.
Mm-hmm. Mm-hmm. Okay.
Are there any further comments, questions, suggestions? If not, then let me thank all the participants for joining the H-DisNet webinar. Furthermore, I would like to thank all the partners for contributing, first to the project and second to the webinar today. And I would like to thank also Marco for managing all the technology in the background so well. I think that worked quite well. Yeah, and let's stay in contact, and I wish you a nice day.